Good morning, bon matin. Ça va bien tout le monde? Everyone doing well? Good, good. Hey, for the AV guys in the back, could I get the presenter view here also? Thank you. Let's give it up for ITI. Thank you very much for hosting this. From what I hear, this is the 15th year of City. It's becoming an annual marquee event that all the prominent players in the Montreal tech scene look forward to every year. I know I look forward to it every year, and I've worn different badges to be here, but very happy to be here in year 15. So thank you guys very much, ITI, for having all of us, and a day full of networking, learning, and just a whole lot of fun. Question for the group. What do you think will be the most talked about topic this year at City? AI. So no one was going to say mainframes? Okay. So you're right. It is AI, and that covers such a broad scope. We can talk about training versus inferencing, machine learning, generative AI. It's such a broad term, and it's such a large scope. Today, I will be talking about the technology that's woven into the fabric of AI, the technology that enables all the AI in its broad scope to take place. So with that said, I work for Dell Technologies. My name's Aati Ahmed. And for Dell Technologies, it all started with the PC in 1984 out of Michael Dell's dorm room. Back then, PCs, they were kind of made for compatibility. Now they're purpose-built. They're being purpose-built for AI. And what I want to do today is talk a lot about AI and a little bit about Dell. Why? Because there is a camera, and I'm sure my boss is going to see this at some point, and he wants to know I represented Dell. But really what I want the takeaway to be is about the technology. If I do my job well here today, there's two main takeaways that everyone in this room will leave with from my presentation, and neither of those two will be about Dell. But since I do work here, I do want to go quickly over the current PC portfolio. Dell did a huge rebranding in 2025. In the past, you might have heard the terms Latitude, Optiplex, Precision. Really strong and passionate following for those products. We're putting those, I'll call it end of life. There's some left behind, and those will slowly fizzle out to make room for the Dell Pro, and Dell Pro Max. The people in this room will probably be in the Dell Pro and Dell Pro Max. Make this easy on the vertical columns. Dell Pro is your laptop and desktop. Dell Pro Max are your workstations. We can go really deep into that, but for the purposes of this presentation, I'll leave it at that. If you want to learn more, come by the Dell booth, and I can do a deep dive. Why are we doing this now? Why the rebrand in 2025? The terms Latitude, Optiplex, and Precision were around since the 1990s. The reason why is simple. It's what we talked about on the last slide. The users are different. The use cases are different than 30 years ago. So with that said, this is a story we've seen before. Right? Like, if anybody wants to put up their hand to age yourself at the right decade, you could do that, or you could keep it a secret. I'm going to keep mine a secret here. But this is how technology is usually taken place. New technology comes out that enables users to work faster and more efficiently, and they start employing that technology before getting IT to approve it, before getting sign-off. And it becomes IT sprawl. Users use it without the proper guardrails that the enterprise would set up for them. The other term for that, I'm sure everyone's heard it, shadow IT. Historically, shadow IT kind of starts with this combative, hey, you're not allowed to use this is not company approved, to really just becoming the preview of what everyone is going to be using, managed, secured, and authorized by the enterprise. The difference this time is the stakes are higher. This is what we call the AI boom, or bring your own AI. And there's a lot of data at stake. It's moving faster than ever before, and a lot more data is at risk than before. You might have heard about the Kubler-Ross model for the stages of grief. Very similar stages for adopting new technology, right? So technology-wise, where do you think we are over here? Grief? Sorry, 3? Yeah. We're probably right around there, right? And a lot like the Kubler-Ross model for stages of grief, it actually doesn't, it's not linear, right? Anybody who's ever been through that, you hope it's linear, but it's not. You kind of bounce back and forth. And that's kind of where we are. So like right now, in general, I think we're at 3, but we're gonna bounce back. Sometimes we'll be back at number 2. Who's heard like, oh, AI is just a phase? Like, you know, sometimes we bounce back into denial. The ultimate goal here is to get to acceptance. This is not a phase. Everyone sees it in their day-to-day, and we're going to go over some examples of the day-to-day here. The point is to get to acceptance, and one of the things we have to accept in this journey, the clock is no longer ticking. The countdown's over. Yesterday was Windows 10 end of support. So if you don't have Windows 10 on your if you don't have Windows 11 on your PC, after this talk, you should like go ask for Windows 11 and make sure you have a Windows 11 compatible PC. And if you don't have that, you should turn in your laptop and ask for a new one that is Windows 11 compatible. There's a lot of risk. You're leaving all your data and everything on your PC unsecured. With that said, if I ask the room, what does AI inferencing look like today? Like, would it, you know, we might have different interpretations, but it would look something like this, right? Like the general consensus of the room would look something like this. The end user interacts with an app. The app sends it to the back end. Back end sends it to the cloud. Whole lot of inferencing and magic that goes on in the cloud. Cloud sends it back to the app, and then the app sends it to, or the end user sees it on the app. Is that kind of like, if you had to draw it out, would your interpretation look something like this for AI inferencing? Right here is where you spend a lot of money. It's uncontrolled costs, and whose budget is that coming from? Is that IT's budget? Because hey, like it's on the app, it's from the device, it's in the cloud. Or is that the user's department's budget? Whose P&L is that coming out of? How are you going to forecast that? How are you going to request budget? How are you going to cap the budget? A lot of questions to answer doing it this way. This way isn't going to go away altogether. The data center and the cloud is going to be a huge part of AI, as we all know. But what we're going to try to do here, and what we've already started, is for a lot of things, we are going to make it happen on device, on edge. So we took that model that has the inferencing happen in the cloud, and we want to bring it to the device. So it's the end user interacting with an app on the device. The device does the inferencing and spits it back out right there in front of you. It doesn't happen in a data center or the cloud where the end user has no idea where that is. You probably are processing it, but the end user has no idea. What's this going to help with? Well, we talked about the costs in the previous model, having everything happen in the cloud and data center. There's also speed to consider. Because it's on device, it's not going up to the cloud and then back down. And so there's latency and security and connectivity as well, all from the device. A different visual of what that might look like. You have on the left AI inferencing in the cloud. So you go command to request to analysis then action. And you see that goes from user to device to cloud and then back down. Now we're going command to analysis and action between the user and device. So we're cutting out, I'll call it the middleman, even though that might not be the best term for the cloud. It is a more direct approach to AI inferencing. And what is going to happen on the device versus cloud? What kind of AI inferencing can happen today on your device? We can look at image generation, agentic AI, real-time language processing, threat detection, code generation, content creation, writing assistance, predictive analytics. What kind of, for all the office workers, I think we're seeing a lot of this already. And for real-time language processing, I see the folks with the headsets probably getting translated real time right now. A lot of that can be going on the device versus in the cloud. Question for the room. I don't expect everyone to know this. What makes a PC an AI PC? Pardon me? The NPU. That's exactly right. So you're going to hear a lot over the coming months and years about what's an AI PC, and a lot of the description will be what an AI PC can do. And it's important to know what an AI PC can do. At the start of this, I said I'm going to talk about the technology around AI PCs. So a PC with an NPU is considered an AI PC. So look at this a way that we might have experienced in the past, decades ago. You had the CPU, right? That's where all the compute, that's where everything your computer needed to do happened. It happened on your CPU. And then the CPU started getting bogged down. Why? Graphics, images, videos, and along came the GPU. Exactly. So what the GPU did, it took all your graphics, video, everything that happened there for the workload, got removed from the CPU, allowed it to run more optimally, while the GPU handled the graphics workloads. If you want to get really technical, we can dive deep on how that all happens, but I'll keep it surface level for now. Now we have a new type of processing that happens, and that's our AI workloads. If we let that happen on the CPU and GPU, sure, we can let that happen. But that's going to bog down your system, slow it down, and it won't be all that efficient to do it that way, and that is why the NPU comes in. It takes the AI workload, processes it on the NPU, and then you have a good balance between the CPU, GPU, and NPU. For a little bit of a visual, this is what it would look like on the chip. You will have your CPU, the GPU, and the NPU over there. And I am sure that right now there are business-minded people and data-centric people in this room that are like, okay, like that, I get it. The NPU is how AI happens on my device. How do I measure that? Right? Like, if that's what you're thinking, it's very simple. This is the second thing I wanted you guys to walk away with. The first was NPU. The second thing is TOPS. It's trillions of operations per second, or you'll also hear it called tera operations per second, which basically means trillions of operations per second. It's TOPS. So NPU is where the AI happens. TOPS is how it's measured. Today, when you have a request for a new computer, it might be accompanied by, hey, I need this kind of processor, an i5. I need this hard drive, 1 terabyte SSD. I need 16 gigs of RAM, or maybe after pandemic, I need 32 gigs of RAM. That's going to continue to happen. And in the very near future, the request for PCs is going to come with a minimum request for TOPS. Today, if you're not working at Dell or a direct competitor of Dell's, you're probably not hearing this. In the very near future, you will be. So to get a little bit ahead, even if you have like a computer science degree and you're very well versed in technology, this is relatively new information. So NPU is where the AI happens. TOPS is how it's measured. You might tell me, okay, Aati, I get it. That's how NPU, that's where the AI happens. and TOPS is how it's measured. But we don't do AI at my company. We don't build apps using AI, and we don't run AI processes. What I would ask you to think about is when you purchase a PC, most customers purchase for a 3 to 5 year life cycle. Do you have the same forecast of not using any AI for the next 3 to 5 years? Let's say that is the case, and IT has not been brought into what is inevitably already happening, and that's AI usage at your company. I would ask other business units, not tied to IT, hey, what are you doing with AI? And I'm sure they're going to have answers for you. No, we're not going to do anything in 5 years, in the next 5 years with AI, and nobody in my company is using it. Then I'll say, you know what, you're not building. But you're already buying. You're already buying software and applications that are utilizing AI, and they're happening on your computer already. Can anyone look at this slide honestly and tell me there's not a single app on there that they don't use in their day-to-day? If you are using these applications for the purposes that each square has its header, your AI processing is already happening on your device. So anything from a Teams or a Zoom call to Copilot to even your security, whether it's Windows Defender or McAfee. How is that all split up? This is what you might be doing. This is how it's split up. So if you might not be able to see in the back, this is the CPU workload, the GPU workload, and the NPU workload. That's kind of how it's split up, right? What does a typical office day look like for you? You might have a Zoom meeting with your boss, a team meeting with a couple of customers, a internet browser open with 12 tabs, a whole lot going on your video with your boss. You might not want him to see all the action in the back. You might be blurring your background, having some noise cancellation. That's AI that's doing that for you already. All right, now we're going to get into different terms with the measurements that we talked about before. Really quickly, I know it was said earlier in this presentation. Let's see if somebody else has it. What makes a PC an AI PC? NPU. It has an NPU. And how is that measured? TOPS, exactly. Thank you guys very much. Now, so that would be, an AI PC. It has an NPU. There's your AI PC. Copilot Plus PC has minimum 40 TOPS. So if your end users are asking for 40 plus TOPS, it's Copilot Plus PC. That's not to say Copilot work can't be done on an AI PC, but if you want a Copilot certified PC, it would have 40 TOPS or more. And then if we're looking at high performance AI PCs, that would be higher TOPS along with higher end discrete GPU. For this, I can talk about this for 15 hours or 15 minutes. I'm not even going to spend that much amount of time on it. If you want to hear about the Dell AI Factory, it's booth 407. A whole bunch of Dell team members are there, and we can talk about the different things here. The point that I want to bring is Dell is not only doing AI at the end user device. As you know, we have a very broad portfolio from data center to end user devices and services. We can go into this story a lot deeper. We have the breadth to cover AI from A to Z. What I really want to look into here, though, is on the infrastructure part, there is client devices down there on the left. I'll continue to speak on those. By 2028, we're expecting 98% of all PCs to be AI PCs. So expect that to come down the pipe. And for the reasons that we discussed earlier, whether it's latency, connectivity, speed, and security, we're optimizing our devices to take that all on. and be one part of the larger Dell AI factory. So why Dell for AI client solutions? I already talked about the end-to-end capabilities of Dell. For commercial AI PCs, we're number one. Leading on-device AI PC innovations. Obviously, everyone is going to come up with these technologies. Dell's competitors also. Dell's leading the way. We're kind of paving the path for everyone to join in on. Most secure and most manageable commercial AI PCs. I will keep it real with you that everyone's going to say they have the most secure and most manageable. It's just how you tweak the metrics. So with our metrics, we believe we have the most secure and manageable PCs, and obviously comprehensive services that Dell does directly, but also more importantly, we have great partners like ITI who can take that on and help you with your AI journey. Earlier in the presentation, I said that the reason Dell rebranded its whole portfolio, whole end-user compute portfolio, was because the use cases changed and the users of IT changed, right? I'm going to go over 4, maybe 5 user profiles, and I'll break it down this way. It's knowledge workers, power users, creators and designers, and AI developers. The top 2, knowledge workers and power users, we'll call those the users of AI, and the bottom 2, which is creators and designers, as well as AI developers, we'll call them AI builders. So for the users of AI, you got an AI PC. We call it Dell Pro Laptop or Dell Pro Tower. You have it here. That'll be between 11 to 16 tops today. Basically, here's a PC. It has an NPU. That's good for you or knowledge workers. Now you're a little bit more engaged on the Copilot Plus. You need a Copilot Plus certified PC. That, on my slide, says up to 50 NPU. The baseline for that is 40. This slide is relatively new. That up to 50 NPU is already old. We already have PCs with up to 80. And then maybe by the end of this meeting, it'll be up to 100, and by the end of the month, it'll be in the hundreds and thousands. It's moving really fast. Oops. So now more to the developer and creator profile for AI. Mid-level workstations for creators and designers. Basically everything we spoke about with the capability to have up to 2 NVIDIA RTX professional GPU in there. Biggest difference between a PC and a workstation. When you ask people that, they'll probably tell you about the capabilities, like we talked about. The biggest difference is the ISV certification. So it has around 140 ISV certifications to be called a workstation, and it is expandable with up to 2 NVIDIA RTX professional GPUs. And on the developer side of that, we have up to 4 NVIDIA RTX GPUs, which are going to help you with that. And of course, an ever-growing number of tops. For now, the magic number is 40. So the threshold that you want to keep in your mind for today, the way everything is 40 tops. I said I might go into the 5th profile. I'll call this the AI super developer. This is for people like who really want to be at the forefront of this and want to develop. They're early adopters. They don't just want to see and consume, they want to contribute. Where does AI happen today? I'm hoping throughout my presentation you would, at least some people in the room would say, like, oh, it could happen on the device. And it does. But the overall, you might say a lot of it still happens in the cloud. I'm here to tell you again that it can happen at your desk. Enter the GB10 and the GB300. The GB300 has server-like capabilities, but it's right on your desk, and the GB10 is right there on your desk. It is not a PC. This is in addition to your PC. You're not going to run Windows 11 on this. You're not going to do your Chrome or internet browsing, and you're not going to do Excel on this. This is specifically for AI developers. So this wouldn't be for your entire fleet. These are for the people who are developing your apps, who are creating new processes and new workloads for your company. You would look at the Dell Pro Max with GB10, which you can, with a single cable, put them together, so you have twice the efficiency of it. And for higher end, you can go to, you can go to the GB300. The GB10 is available now. The GB300 will be early next year. And this is kind of like the hierarchy, right? You go from the GB10 to fixed workstation with the RTX Pro graphic card, and then up to the GB300. And then obviously for the very high end, we're not removing data center and cloud from the equation. We're finding a more efficient way to work with it. So these are just some speeds and feeds on the GB10. I said at the beginning there were two things I wanted everyone to walk away with. It was the NPU, that's where the AI workloads are happening, and it was TOPS, that is the measurement for AI. Like that is what your requests are going to come in with. So NPU and TOPS, please take that away. It might sound new and not super interesting right now. All your users will be asking for this in the months to come. To everyone in the room, thank you very much for being here. I will be at the Dell booth. Merci beaucoup. Thank you guys very much.